online teaching platform, still on how to determine the derivative of a given function from the first principles. So we are still looking at rational functions involving radicals. So we are to find the derivative of the given function from the first principle. So let us start with, we have our function to be our f of x to be 1 divided by the square root of x. So this becomes the original function. Let us find our f of x plus h. So we are dealing with a small increment in the h. So we have our f of x plus h to be 1 divided by the square root of. So wherever you see x in the original function, you plug in x plus h. So since we have x inside the square root, we are going to replace it with x plus h. All right. So let us now state the formula for finding the derivative of a function from the first principle. So since we are to find the f, the x, that is, we are to differentiate the function f with respect to x, we can say that let y be equal to f of what? X. So we can now use dy dx. Alright, so it's going to be dy dx is equal to the limit as h approaches 0. Then we have our f of x plus h minus our original function, which is the f of x, all divided by h. So this is the formula that we'll be using. Since we have the various components, let us plug in the various components. So we are going to get our, so we have our limit as h approaches 0. Our f of x plus h, we had 1 divided by the square root of x plus h. Then our f of x is the original function, which is as 1 divided by square root of x, everything divided by h. So divide through by h. Alright. So let's continue to simplify. So we need to simplify the two fractions. First, so we have, write by limit well. We have the limit as h approaches 0. So let us find the LCM of the two fractions. So the LCM will be x square root of x plus h, the product of their denominators, times the square root of x. Alright. So when you take the first fraction, the denominator of the first fraction divides the LCM, we will be left with the square root of x. So square root of x times 1 is the same as square root of x. When the second denominator divides the LCM, we are getting square root of x plus h as the result. So we are going to use it to multiply the numerator, which is a negative 1. So negative 1 outside, then square root of x plus h. Alright. Then all divided by h. All divided by h. Alright, so we continue to simplify. So we'll be getting the limit as h approaches 0. And let's just work on the numerator. The numerator, we are going to get square root of x minus the square root of x plus h. Then the denominator, we are getting square root of x multiplying square root of x plus h. Then we divide everything by h. Alright. We continue to simplify. You have the limit as h approaches 0. Then we could see that the numerator has a set minus another set, so we can use the conjugate of the numerator to rationalize the given expression or the given radical expression. So the conjugate of the numerator will be the same thing, just that where we have the plus, the minus, the square root of x minus the square root of x plus h becomes square root of x plus square root of x plus h. They use it to multiply both the numerator and the denominator of the fraction. So let us repeat the original fraction, square root of x minus square root of x plus h divided by square root of x multiplying square root of x plus h, then so you put it in bracket nicely, times the conjugate. So times the conjugate, we are going to get square root of x plus the square root of x plus h divided by the same thing, square root of x plus square root of x plus h. Then you close it nicely. Then you divide everything by the h. Alright, so let us continue to work on it. You'll be getting the limit, as h approaches 0. So you can say that the expression, the numerator, square root of x minus square root of x plus h multiplying square root of x plus square root of x plus h. We can apply the concept of difference of two squares. So we'll be having the square of the first term is square root of x all squared minus square root of x plus h also squared, and that is the expression for the numerator, because the conjugate of the square root of x minus the square root of x plus h, whenever you multiply it by its conjugate, you are getting difference of two squares. So the first term squared minus the square of the second term, all divided by, so we multiply the denominators as well. So we have square root of x multiplying, square root of x multiplying square root of x plus h multiplying square root of x. So the square root of x times the square root of x will give us x. So that is square root of x squared. Then we have our square root of x plus h. Then we continue, then plus square root of x multiply square root of x plus h, now multiplying square root of x plus h. So we are going to get square root of x, then bracket open, square root of x plus h all squared, and everything divided by the h. So we have the limit as h approaches 0. So we are going to get, can now simplify further. So this cancels this also cancels this cancels this also cancels this. So you'll be left with x minus the bracket open x plus h, then all divided by x multiplying square root of x plus h bracket plus square root of x also multiplying x plus h in another bracket. Alright. Then all divided by the h. So we continue to simplify. We are going to get a limit as h approaches 0. So we have our we have our x here minus this x. We are left with negative h as the numerator, all divided by, we have here to be x multiplying square root of x, square root of x plus h, then plus square root of x also multiply x plus h in bracket, all divided by h. Right. So we continue to simplify. This will give us the limit as h approaches 0. We have negative h here. Then all now be the denominator will repeat the same thing, x times the square root of x plus h plus square root of x multiply x plus h in bracket times 1 divided by h. We are now going to change the division to multiplication. So the h becomes 1 divided by h, so that the sign changes to multiplication. So that becomes the reciprocal of the h. So we continue to simplify. Our h here and this h will cancel each other. So we are left with the limit as h approaches 0. Here will be negative 1, all divided by x and square root of x plus h, and plus square root of x multiply x plus h in the other bracket. So now we can take the limit, cannot take the limit, so it will be negative 1, then here will be x plus the square root of x plus h. Now the h is equal to 0, so wherever you see h, you put 0 over there, then continue to work on the rest plus square root of x multiplying x plus h, and the h is 0. So, alright. So, we now get negative 1 divided by x times the square root of x plus square root of x also times x. Right. Since we know that multiplication is commutative, square root of x times x is the same as x times square root of x. So we are going to get negative 1 divided by x square root of x plus x square root of x. Now you can see that these are like sets. So we have like sets, right? So we can add 1x to another 1x, and that will give us 2x. Alright, so we are going to get negative 1 divided by 2x multiplying the square root of x to be the df dx, meaning the derivative of the function f with respect to x. We conclude that therefore our df dx is equal to negative 1 divided by 2x multiplying the square root of x. Thank you for watching, and do not forget to subscribe to my YouTube channel, which is Math with Ebefa. Bye.